So, good evening, guys. Slowly, the students are trickling in. Okay, we are in PDA. Just to touch base where we are. Don't tell me we are at LT1. Yes, we are at LT01. But in terms of topics coverage, we are at PDA. And those who are under my tutorial slots, of course, I have covered the example problem on palindrome the week before the mid-semester, not mid-semester, the week before the last week, that was Independent Learning Week, okay? So I have discussed during our lecture slot the example problem that has been solved here, that was on palindrome. Then those who are under my tutorial batch, I have already discussed question 1A, 1B, and 1D. Don't worry, I know, I just checked with Yogeshwaran. So he confirmed that with this tutorial batch, he has covered only 1A and 1B. Okay? So today I am going to discuss 1C, even though it is an assignment 1 task, but I am going to solve and show you, because I am going to introduce one new instruction in PDA which I have not discussed yet. Okay, so I am going to discuss that today to make your life easy. So question 1C I will discuss now, and 1D I have discussed with my tutorial batch, but don't worry. Those who are under Yogeshwaran, I will tell you the answer for 1D. Not tell you the answer, I will tell you how to do 1D. It is like that, you can do it, no issue. And those who are under my tutorial batch, I have discussed question 2 as well. But I understand those who are under Yogeshwaran, you have not discussed question 2 and 3 yet. Okay? So I will do question 3, which is also an assignment 1 task, but I will do in class today just to make your life easy. And if time permits, I will do question number 2 as well. Okay, so the entire PDA would have been covered by today for both under my tutorial batch as well as Yogesh tutorial batch, so that you have enough time before you go for the test next Thursday. Okay, I have already sent a reminder yesterday night through my times that next Thursday is a test. Take it seriously. Okay, if you are sleeping, I cannot help it. Please help me to help you. Okay, and you have to understand this is a university. We have university policies and procedures. Okay, yeah. Why I am telling this is, I understand. I also been a student. Students are students. Very sad under my master's class, Masters in Applied Computing. For this April semester, I have in class only 18 students. Okay, and all these 18 students, all not even one class, one of them was absent right from day 1. I do actually for them the class only 7 weeks because we go by blocks, but double the hours. So per week I do 8 hours for them. So Friday, for example, tomorrow I have a class with them. Friday I have 6 to 9 here, face to face. Then Sunday 9 to 2, 5 hours. Okay. So Friday 3 hours is tutorial, Sunday 5 hours is lecture online. 8 hours per week, but they go only for 7 weeks. That's it. 8th week they go for exam and they complete the syllabus. I mean, they go for exam and they go to the next block. What happened yesterday? First block is over. So tomorrow we are going to have exam board. So I was entering the marks because I never check the CMS because attendance you take through camps. I never go into the manual system. I go into the manual system only if somebody says I missed to take the attendance or my app is not working, can you enter my attendance? Then I go into CMS. For this class, unfortunately, I did not go to CMS because, as I said, very surprising to me. Right from week 1, not even one student was absent. All 18 will be there. Friday, Sunday, all it will be there. So I assume there are only 18 students in the class. While I entered the marks yesterday night, I saw in the class there are 19 students. Like you, they also have 4 assessments, Two now they don't have test, but they have 3 assignments and 1 final assessment, 4 assessment. When I entered the marks, I see 19 students. And this guy, to me, is a no-show, I was wondering, what is it? And today, surprisingly, I want to email him, telling him, hey, are you registered? Because the system shows he is registered and his name is there in the CMS. His name is also there in My Times, Today, I wanted to email him, asking him, hey, you are registered. How come you did not even show up for any of your classes? So it means, no show means you are failed, Before I could email him, he emailed me saying, sir, I want to see you Friday. Can I have an appointment? I said, yes, I'm going to see him tomorrow. But you see, what I'm trying to tell you is not to complain about that student, but I'm sharing, this is what happens with some students. In this scenario, I can't help him because semester is over already. And I don't know how, I really don't know whether he slipped to attend classes or knowingly he did not attend classes. I don't know. I don't think so because he has asked me to see me about his performance. I don't know. Semester is over, So what I'm saying is, your class has 178 students. In none of my Thursday lecture class, I even had 150 students here. You can see here, hardly it will be 100 students. I don't think so, there will be 100 students here. Okay? So, I understand, it's up to you. You are paying 100 plus thousand, it's up to you whether you want to come to class or not. I can't force you. I'm not working with PDRM to chase you. Because I'm not a policeman to chase you, Hey, you have to come to class, no. Okay? So, take the test seriously. As I said, help me to help you. Help to help yourself as well. Okay? Yeah, if you miss your test next week, I can't help it. Okay? And you cannot ask for replacement test. Replacement test will be given only if you fall sick and you provide MC that you were sick on the day of the test, you cannot come. Only then, because as I said, it is not me framing these rules. The university has a policy. It has policy we have to follow. Otherwise, we will be punished. Okay, I'm working for this university. I have to follow their rules. Yeah, it's not my rules. Don't get me wrong. Okay. So next Thursday, I'm telling you, I know not everyone is here, but I have sent a message through My Times. I will send another reminder tonight also. Okay, that next Thursday during our class is your test. Okay, supposed to be today, but we pushed to next week because to cover the syllabus. Okay, and some of you have a question. Question paper will be given or not? Where am I to write my answer? Don't worry. I will give you question paper already printed. I will issue the question paper before you start your test. I will give you answer booklet exactly like what you receive in the final exam. Same answer booklet I will give you. Okay? So you just need to come. You need to come physically with your pen. That's all. Okay? Just come with your pen. I will provide you question paper and the answer booklet to answer the test. Okay? So some of you may ask how many questions, what is the pattern of question, can you give me the question paper? I cannot give the question paper, but I can show you the pattern, and I also told you this many times in the class, but never mind, I am telling you one more time because just hardly 1 week. So this is your module site. If some of you have never been to this module site on My Times, and if you go all the way down, you go all the way down, you see, written test conducted face to face, test Thursday 27. What? This has been there from day one, the semester started. Only one thing I have changed, that is the date. It was today. Supposed to be today, from 20 June, I changed to 27 June, that's all. Otherwise, it has been there from day one. Okay? So it says topics coverage, tutorial 1, 2, 3, and 5. Actually, we are discussing 5th tutorial. It's also test will be 3 questions. Question 1 will be on language and grammar. Question 2 will be on NFA, DFA. Question 3 will be PDA. It also tells for a given language specification, you have to construct a grammar. and then determine whether the grammar that you have constructed is ambiguous or not. That's all. You can use past three, you can use derivation. Okay, it's up to you. If you ask me, sir, can you recommend? Yes, I will recommend use derivation. Okay, derivation is faster. You can do it faster, easier. Past trees, in my experience, I see students, a lot of them make mistakes. Okay, and question 2, you will have A, B. Question 1 also A and B. Question 1A will be to construct a grammar. Question 1B will be to determine whether the grammar that you have constructed is ambiguous or not. Okay, don't look at your neighbor, because you may have ambiguous grammar, your neighbor may have unambiguous grammar. It depends on the grammar, how they write the production rules. Okay, not everyone will get the same answer, ambiguous or unambiguous. Okay, question 2 will have section A, section B. Question 2A will be to construct an NFA. Question 2 will be to convert that NFA into a DFA. Okay, question 3 I have given here will be to construct a PDA for a given language specification. So question 3 has only section A, no B. So A will be similar to what we are discussing in the tutorial, to construct a PDA, that's all. Okay, to construct a PDA. All right. So you can check here in case you still don't remember what topics, how many questions, what type of questions, Students means will have all these questions, don't worry. Okay. So all these are answered here from day 1. And even exam also, it is there. Exam topics, I put it at the very upfront of the module side. You see here, announcement. Okay, it is there on the module side, so no need to take picture. It is there on your hands. If you have internet access, you can go to the My Times module site, you can see. Okay, it won't be deleted until your exam is over. Okay, yeah, even after exam is over, I never delete it. You can see all the past modules are there. Theory of computation, March 2023, August 2023, all are there. Okay, so nothing is deleted, it's there. So you can see until you have finished this semester, your module site. Yeah. All right, let us not waste time. It's already 14 minutes gone. I need to finish the tutorial. Okay, so let us finish, and we have time. I'll stay here. And any questions you have, you can clarify, no issue. Okay. So 1A and B done for Vigneshwaran, Yogeshwaran batch also. So I'm jumping to 1C. 1C says the language L is equal to set of strings that are element of A or B Kleene star. This colon means, so I have also given here, the colon symbol is synonymous. Synonymous means the same to the symbol vertical bar. The vertical bar, we read it as where. Okay. So this colon also means where. Okay, set of strings that are element of A or B Kleene star, where the string has twice as many B's as A's. Okay, twice as many B's as A's means so you need to have immediately. You have to think of example strings. Okay, so I am going to give some example strings here. I stop here. Okay, so why I stop here means, again, it's natural for students to ask, so how do you stop with the number of example string? I've told this many times, whether it is grammar, NFA, DFA, or it is PDA, the requirement remains the same. I look at example strings to look at the pattern of strings. Okay, so to me, this language will produce only these pattern. These pattern means these 3 strings will be like the fundamental building block. Only 3 different patterns. All other string will be a repetition or a combination of these 3 strings as building blocks. I will show you. So if you see this is nothing but this is repeated 2 times. You can have 2 times A, 4 times B. This BAB is here. This ABB is here. Okay. So you can see these all are combination of these pattern of strings. So these pattern of strings act like your bricks, fundamental building blocks. So all other valid strings are going to be some combination of this. So what I'm trying to tell you is, if your machine accepts these strings, these 3 strings, your machine is going to accept all other valid strings. That's it. Okay? Yeah. So how to construct this machine? Okay. Okay, so let me bring the stack. So stack is, I'm showing the stack only for your understanding, okay? So to visualize the working of the PDA, okay? So not necessary for you to not necessary for you to show the stack in the test or in the exam. Not necessary. Yeah? There's no marks for the stack. I show the stack for you to understand how we construct the machine. So here, A, B, B, right? My thought process is A means I am going to push 2 A's into stack, similar to your question number 1A, right? Similar to your question 1A. Yeah? Similar to question 1A, I push 2 A's into stack. Y means if I have 1A, I have 2 B's. So my thought is 1A means I push 2 A's. For every B, I pop an A. Okay. So A means I push an A. So for B means I pop 1A. B pop A, B pop A, B has been processed. Okay. Same concept I am going to apply for BBA as well. Some of you in my tutorial class you asked, so like you push 2 A's, can I pop 2 A's or can I pop 2 B's? Also had a question, can I pop 4 A's? Yes, if situation demands, you can push any number of A's. You can pop any number of A's, no issue. Okay. So I'm going to apply the same thought. Like I did, A means push to A. So for every B, I popped 1A. So I'm going to apply the same thought here. So what I'm going to do is to process BBA. So B means I am going to push 1B. Okay, B means I push B. Then again B, right? So again B, yeah. So my thought process is to push B again. Okay, come to A. Like I'm going to say A means pop to B. Okay, I'm going to say pop to B. So this thought process I'm going to apply to the machine. I'm going to apply this thought in constructing the machine. BAB, don't worry, I'll come to it shortly. Okay, so I'm going to say if the input is A, currently the stack top is lambda. Stack is empty, yeah. So currently on the top of the stack we have nothing. So I put that here as lambda. So currently on top of the stack is nothing, empty, lambda. So I'm going to replace it with capital A. I'm going to replace it with capital A because so this means A means we are going to sorry, not 1A, I'm sorry, push 2 A's, right? Push 2 A's. Okay, so and then so B means I'm going to do it at Q0 itself. I'll tell you why, you will understand shortly. So B means I'm going to say pop an A. I think I should use the whiteboard, like this takes time. So B means I'm going to pop 1A. So I'm going to say A replaced with lambda. Okay. So if I do that, then this state should be a final state. Okay, this state should be a final state. So I'm doing this to process this in this string. So A means the machine is at Q0. A means I push 2 A's into the stack. So A has been processed. So B means I'm still at Q0. B means I'm saying pop A. Again B, pop A. So ABB has been accepted. ABB has been processed. Q0 is also final state. Stack is empty. Hot and accept. Okay, so Yogeshwaran batch, please remember, before you process a string, stack must be empty. After processing a string, the stack must be empty, and the machine should be at the final state. Okay, all these conditions should be satisfied for halt and accept. Okay, so for BBA, I am going to do it at Q1. I'm not going to do it at Q0. I'm going to do it at Q1. So if I want to go from Q0 to Q1, I have taught you this during lecture previously. You would have forgotten, but never mind. I can explain again. I am going to do something called as lambda transition. This means when the input is nothing, okay, this lambda means input is nothing. Okay, that position stands for input alphabet. So when the input is nothing, do nothing. Do nothing means neither push nor pop. Okay, so this position is for the current stack top, and this position is for the new stack top. So input is lambda, then lambda stroke lambda means don't do push nor pop. So it means do nothing to the stack or ignore the stack. Okay, so doing nothing, the machine goes from Q0 to Q1. Doing nothing, the machine goes from Q0 to Q1. At Q1, I am going to process BBA. So what I am going to do is, I am going to say B means push push 1B, yeah, and A means I am going to say pop the B. So B means I am saying push B onto the stack. So again B, right? So again B means push B onto the stack. So A means we should pop 2B. So I put 2B here. A means pop 2B. So both the B's will be popped off. Okay. So now you are seeing example. Like we push 2 A's, we can also pop 2 A's. So I'm popping 2 B's. Okay. So ABB and BBA has been processed. So now I have to process BAB. Okay. Observe me carefully what I'm going to do. So for BAB, I cannot use this instruction because this instruction says B means currently the stack top is, on top of the stack is A, you replace it with lambda. Meaning B means at Q0 it says pop an A. Our stack is empty. So we cannot pop an A from an empty stack. Correct, right? So I cannot use this instruction. So I am going to go to Q1. For BAB here, I am going to use this lambda transition to go to Q1. Okay. Doing nothing, I go to Q1. Okay. Doing nothing, I go from Q0 to Q1. Now I am at Q1. Here I have an instruction. B means push B. So I am going to use this instruction. Okay. To process this B. This B. So I am saying B means currently stack top is empty. I am replacing it with capital B. Okay. So I push B here. Now I have to process A. Usually, so far the machines we have seen so far, we say push B means pop B, or push A means pop A. This is what the pattern of instructions we have seen so far. Push something, pop something. Okay. So here I'm going to use a new instruction which I have not taught you so far. Okay. So what I'm going to say is, I have A here, but here the machine is still at Q1, right? A means it says pop 2B, but I have only 1B, I cannot pop 2B, okay? But if you observe carefully, after, this is we call it as look ahead mechanism, okay? Today, we exploit this look ahead mechanism with the help of machine learning a lot, okay? Yeah, in terms of analysis, predictive analysis, prescriptive analysis and all that, okay? So this is a sort of looking ahead. Okay, so I have currently A, right? I'm also looking at, after solving A, I have B next. So I also look at how to solve B such that I also can solve A. Okay, so I'm looking at the future, looking ahead. Okay, so if you, after solving A, I have to solve B. If you look at Q0, I have an instruction here. B means pop A. Okay, B means pop A, yeah? In the stack, I have B. If I have an A in the stack instead of B, I can exploit, I can use this instruction. So what I'm going to do is, I'm going to transit from Q1 to Q0. I'm going to go from Q1 to Q0 to process A. So I'm going to say if the input is A, okay, replace B with A. I'm going to say replace B with A. That is, I always think in terms of a processor, how the processor thinks. If the input is an A, processor will do this. Read B, write A. Okay, read B, write A means currently the stack top is B. On top of stack we have a B. Replace it with A. That's what we have been doing earlier. Okay, so when we say B means A stroke lambda, currently at the stack top we have an A. Replace it with lambda. So here what I am saying, A means currently at the top of the stack we have a B. So you replace it with A. So meaning I am going to go from Q1 to Q0, processing this A by replacing this B with an A. So we are not pushing or popping. We are reading B, read B, write A, or replace the B with A. This is the new instruction. Yeah. So I replace the B with A, I go to Q0. So now the machine is at Q0. What is the next alphabet to be processed is a B. We have already an instruction here. B means pop A. Replace A with lambda. So I replace A with lambda. So BAB has been processed. Stack is empty. The machine is at final state. Halt and accept. Okay. Only thing I have missed is for BBA, the machine is going to process here, right? B means push B. B means push B. A means pop do B. So Q1 should also be a final state. I missed that. Yeah, done. So I want the two rings to be visible. So it's a final state. Okay, done. That's all. Okay. Any questions before I go to the next problem? Yeah. For BAB, I'm not using this. For BAB, I'm going here. For BAB, I said I'm going from Q0 to Q1 using lambda transition. And for this B, for this first B, I'm using this instruction. B means push B into the stack. Okay. So next is A, right? A means I cannot use this instruction because this instruction says A means pop to B. In the stack, I have only one B. So what I do is I go from Q1 to Q0 and I put an instruction here. If the input is an A, replace the B with A. So here B, we have B here, right? So I'm saying replace it with A. So I have A now. Machine is at Q0 and the next alphabet to be processed is a B. So here B means I have an instruction replace A with lambda. So I am replacing A with lambda. It means pop A. You're welcome. So I have solved this. So what I'm going to do is I'm going to jump to 1D. 1D, when we say